Give me a silent thumbs up when you think you know what his thought process was. So I know, Isaiah, you're his partner, so you're able to see that. So I see one person understanding. Maybe put your hand up so I can see. Oh, I see 2 people understanding, 3 people who understand, 4 people who are understanding. All right. So Samantha, can you try to explain to us what you think Carlos was doing?
I think Carlos's thought process was kind of the same to Joffrey's, where he was splitting up each box into 12 pieces.
Okay, so Carlos, first of all, do you want us to look at this part or this part? Or both? Both, okay. So let's first count how many circles there are. Can you guys count with me? Ready, and go.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
And what do these 12 circles represent?
Kids.
12 kids. And Carlos, you did such a good job labeling. Remember I told you guys to label so you guys don't confuse yourselves? So he labeled the 12 kids. Awesome. Now, what are these boxes? Let's count them. Ready, go.
1, 2, 3, 4, 5, 6, 7, 8.
Okay. What are these 8 boxes for?
Clay.
The packages of clay. And he wrote 8 boxes split into 12. So that's why he has 12, 12, 12, 12, 12, 12, 12. And then he said there are 8, 12. So can you now explain to the class what these dots represent? Go ahead.
These dots represent each of 1/12 in each box.
So can you pretend you're actually going ahead and putting the box? I want to see your thought process. Go ahead.
1, 2, 3, all the way to 12.
So you're taking this one box, you split them into 12s. He's taking 1/12, putting it here. 1/12, 1/12, all the way until everyone gets 1/12. And then what? Then you crossed it off. Then he went to the next package of clay, Dennery, pencil down. Then he gave it another 12, another 12, another 12. When he gets to this box of packages of clay and he gave it to everybody, how many 12s do you think each student had?
32.
Let me ask the question again. When he's at 1, 2, 3, the 4th package of clay, and he distributed the 4 clay so far, how much of the clay did each student get?
12.
How do you know? Tell your partner how you know that. Go ahead.
So each kid got 1 top. And he split it to half and give each.
All right, 1, 2, 3, eyes on me.
1, 2, eyes on you.
Respect. Thank you, Alvar, for your respect. Thank you, Isaiah. Thank you, April. Kevin, can you explain to me when he got to the 4th package of clay and he already distributed the clay, the 12ths, right? How much of the fraction of clay did one student get?
The fraction of each student got is 1/12 because every time he finishes one box, he adds only 1 more to each circle.
Awesome. Who can build on to what Kevin's saying when he says they get 1 more? 1 more of what? What does that mean, 1 more? Ruby?
1 more piece of clay.
Okay, so let's get a little bit more specific. We said 1 more piece of clay, but what exactly is that piece? Samantha?
He gets 1/12 of the piece of clay.
Carlos, is that correct? Awesome. So we are able to understand that each student got 1/12 of the package of clay each time. So since we have 8 packages of clay and 12 students, every student got 8/12 of the package of clay. Awesome. Good work, Carlos. All right. I would like for Eileen, can you bring yours up, please? All right, so when I put Eileen's up here up on the board, I'm going to give you about 15 seconds. And we can down here. Let me give you guys about 15 seconds to really take this in. Okay, so without discussing to your partner yet, I want you to silently look at it.
4, 6. It could be different. It's different distraction.
Multiply.
1, 2, 3, eyes on me.
1, 2, eyes on you.
Thank you, Isaiah. Thank you, Robert. I'm waiting for you. Thank you, Robert. All right, Caesar. At this time, I want you to discuss with your partner, what do you notice about Eileen's work? And she worked with Samantha. So instead of talking to me, I want you to discuss to your partner, what is it that you notice and what connections can you make to what we taught, what we learned in class? Go ahead.
The same as 8, 12. Earlier Carlos had 8, 2, 4. 6 times 2 equals 12, and 4, 2 thirds. It mentioned another 2 thirds. So, and then one's one.
What was similar or different between this and Carlos's strategy?
Carlos is like 4,
Hers is
6.
an equivalent fraction.
What's that?
Hers is an equivalent fraction, and mine
Because
is the
it
actual.
multiplies 6 times 2, it turns 12, and then 4 times 2 turns 8, so it's 8,
She just
12.
divided the numerator and the denominator.
So she simplified the fraction?
Yeah.
Do you think it could be further simplified?
Yes.
Yeah.
Or is 4 6
2/3.
2
2/3? Okay.
Because you multiply 3 times.
Okay.
But there's another one.
I'm gonna check out your work as well.
I got a wrong answer. Yeah.
Voices off, eyes on me in 3, 2, 1. All right. Who can raise a hand to explain to me what you think that Eileen and Samantha did? Okay, Caesar, take it away. Go.
I think they did it.
Can you tell me like the steps of what you think they did?
They first started like with all of them. They turned it into halves.
What is all of them?
All of those clay.
So you're saying these represents the clay? Okay, let's just count them to make sure. Ready? Count with me, go.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Oh, okay, let's try that again. Ready, set, go.
1, 2, 3, 4, 5, 6, 7, 8.
Okay, so I have to look at her diagram. It says split 8 into halves. So first she split them all into halves. Then what do you think she did? Look at this.
1 half.
So Caesar's saying she gave everyone 1/2. That's why everyone has 1/2 in their circles, okay? This represents the children. Then what do you notice that she does? Ruby, go ahead.
She has 2 extra packages of clay.
Pause. So she has 2 extra packages of clay, which she actually brought over here. Can she give another half to all 12 children?
No.
So what does she do next? Who can build onto this? Who can build onto this story? John? You're thinking. Okay, keep thinking. Avril?
She split it up into 6.
She split them up into 6. She actually wrote that down. She says there's 2 left, so she split it into 6. Does she? Let's see. 1, 2, 3, 4, 5, 6. So how many 6 does she have total?
12.
12, 6. Okay, so then what does she do, Jofer?
Then after she got the 1/2 and 1 6.
So she put 1/2, she added 1/6 to each of the students.
And she then added it like the normal.
Okay, I'm gonna zoom into this part now. Good job, guys. We are really working hard today.
She found the least.
I'm so fascinated by this, and this gets me so excited. Why do you think this gets me so excited? Marcia, explain to me why this makes me so excited.
Because Eileen used a strategy and she multiplied the denominators and the numerators.
So first of all, when in each circle, when she says everyone got 1/2 and 1/6, can you add 2 fractions with unlike denominators?
Yes,
The one in the middle looks like
How? How can we add them?
You have to find the least
Hold on.
multiple.
What is that called, Ruby?
You have to find the least common multiple.
The least common multiple. So look at her equation. Is everyone looking? Kelvin, put your pencil down. Thank you, Robert. So she wrote 1/2 plus 1/6. And what is all this that she's doing? What is this that she did right here? Deonzi, explain to me what this is.
what this is she was dividing 6 out of 2 and apparently she got 3. So she multiplied 2 times 3 and she got 6. So she added it on the bottom.
Okay, so what you're saying is she found the multiples of 2 until she found, what is that called?
The least common multiple.
Okay, the least common multiple. So that's her new denominator. So she wanted to create what kind of fractions?
6.
What are they called? Equivalent fractions. She created equivalent fractions with the same denominator. So she multiplied 2 times 3 because that's the third multiple, right? So 2 times 3. Whatever you do to the denominator, do to the numerator to keep it an equivalent fraction. So her new fraction is 3/6. Does she have to change 1/6?
No.
No, why not?
Because it's already a fraction. It's already
It already has a denominator of 6, right? So then she found her new equivalent fraction of 3/6 and was able to add it to 1/6. Can you add like denominators? Yes, you can. So she was able to add 3 plus 1, which is 4, and her denominator was 6. So in the end, how much of the clay did each student get?
4.
All right, well, let's pause for a second. So Eileen got 4/6, and Jofer got
I got 4
8/12.
Me too.
Are these both correct?
Yes, equivalent.
Miss, also 2/3.
And 16, 24.
Let's try this out real quick. All right. So we have 4/6 and 8/12. Let's see if this is correct. So we're going to first start off with the 4/6. Let's prove that these are equivalent. So we're going to create 4/6 right now. 1, 2, 3, 4. Whoops.
That's 5.
5 and 6. Is that right? 1, 2, 3, 4, 5. Wait. 1, 2, 3, 4, 5, 6. Okay. So we have 6 here. How many should I shade in?
4.
Okay. So 1. Can you say 1/6?
1/6.
Next.
2/6. 3/6. 4/6.
Okay. Great. So that's what 4/6 look like. Now let's create another one. And remember, they have to be equivalent. How can I make this into 12?
Split it in half.
Split it in half. So my denominator is 12. Let's see. How much do we need to shade in? 8. Ready, go. 1 12.
2 12. 3 12. 4 12. 5 12. 6 12. 7 12. 8 12.
Discuss with your partner if you think they're the same and how you know.
And the model is the same. All you needed to do is split it in half. So you just need to multiply the denominator and the numerator by half. I mean by 2.
Respect. Thank you. All right. So, are they equal or are they not equal? Stand up. Stand up if you think they're equal. All right, Caesar, come on. All right. Okay, so we think they're equal. Good job. Have a seat. Who can explain to me how you know they're equal? Isaiah, go ahead.
I know that how they're equal because there's 2 things you can just take off the whole line in the middle and then
So
it'll be
take this
equal,
line off.
and it'll be equal still, and still it's a cube.